Hello guys, welcome to another session. In this session, we are going to look into Numpy array internals. So let's look into the topics which we are going to cover in this session. So in this session, basically we will understand that how to know about what is the dimension of an array. Then we will also look into how to get the information about shapes of Numpy array. And at last we will also look into what actually the strides is. Strides is little bit complex topic. Initially, you will find it difficult to understand it, but it is very important concept. That's the reason I brought it into this session. So let's jump into the Jupyter notebook where we will understand with the lab. So we are into the Jupyter notebook and we are into the same notebook which we have created in our last session where we have learnt about how to create array within Numpy. Now I am going to use the same notebook for this session. So the first question we are having over here is what actually the dimension in array is. So in a layman term, I can say that dimension of an array is the number of indices or subscripts that you need in order to specify an individual element of the array. So what does it mean? For example, suppose that if you are having a 1D array or say a list, so I can tell that array 1D equal to, this is also known as list within Python. If you are having some element within that and if you want to access these elements, so you need to use one indices. So what it means, so to access the first element you need to specify 0 as an indices to access this number 12. So shift enter, if you will print it, print, and over here shift enter, then you will find that it is returning us the number 12 over here. Same way, suppose that if we are having a 2D array, and just take an example of the above one. Over here I am going to take this one. So take it and put it over here. So it is going to generate a 2D array with the range between 30 to 50. So shift enter. Now let's look into what it has returned so that we will access the individual element. So shift enter, then you will find that it has returned us these elements. Now suppose if you want to access these elements, the element 49, so how do you access? So to access this we need to access two dimensions, that means two indices. So you need to specify over here 0th position and again the 0th comma 0. So over here I am telling that can you please return me the element which exists at this position. So how we are accessing it? With the help of two indices. See here, and if you will print this, then it will return us the number 49 over here. So you will see that it has returned us number 49. So that is what the definition is saying. So this is about the definition of the dimension of an array. But here the question is, how do we get to know that what actually the dimension of a particular array? So to get it, you need to use a method which is provided within Numpy with the array. So for example, suppose that if you are having a 1D array, you just take it, copy it and paste it, and there is a method called ndim. But prior to using this, you should make sure that you are going to convert it as a nd array because it is a list over here. I have just created a list. I haven't converted it as an array, which you supposed to convert it first into Numpy array and then you will use it. In the last session I have showed you. So to create the list as an Numpy array, so what you need to do, you need to specify over here. I'm going to create a variable 1D array, and over here I will specify np.array, and within that I am going to specify the name of this list and what kind of value it is going to store. It is going to store d type equal to int16. It is a 16-bit. I am going to cover this one in the stride section, the int16 in more proper manner, as it is basics of computer, but still I will cover in this session. So let's do shift enter. I forgot to mention over here it should be np.int16. Shift enter. Now it has taken. Now if we will apply over here, just take this one and put it over here, shift enter, then it will return us the dimension is 1. That means you can access the element with 1 indices as per the definition of dimension of an array. Now moving further, suppose that if you are having this and you want to get to know about this array, what actually the dimension is, you can easily know it with this property and dimension. Sorry, earlier I have mentioned about it is a method. It is not a method, it is a property. So I apologize for that. So it is a property. So now to get to know about what actually the dimension of this, so it is pretty much straightforward. I have already mentioned, so you can copy this one, put it over here, and here you need to specify the name of an array and it will return the dimension. Shift enter and you will see that it is a 2D array because we are accessing the element with 2 indices. Now let's proceed further. The next thing is what actually the shape is. What is shape? So shape is nothing but a number of elements exist within each dimension. So let's understand with an example. For example, earlier we are having a 1D array, and if you want to get to know about the shape, then let's look into that how to get the shape. So there is another property available that is called shape. So let's write it, array 1D array dot shape and shift enter, then it will return that we have 3 elements at row level. So if you will look over here, it is a list. We have converted it into a 1D array with the help of np.array function, and now it is telling that we have a single dimension array and which contains 3 elements. Now let's proceed further. Let's look into the shape of array 2 dimension. So here we will mention 2D dot shape. Now let's look into the output, what output it is returning, and you will see here it has returned 2 elements at row level and 2 elements at column level. So this way you come to know about what actually the shape is. So now we have understand about what actually the dimension is and what actually the shape is. Now I am moving further and we will look into a stride. A stride is little bit complex concept. If you are not understanding in a first instance, that is perfectly fine, but I will try my best to make you understand. So first understand with some basics. Suppose that if we are having an array, a stride array, I can tell it, and over here and we are having 2 list, I am going to create an array with 2 list, and within that over here I will specify 2 list over here. So over here I will specify 1, 2, 3, and then we have another array that is 4, 5, 6, and that is also inside another list. And now I am telling that the D type should be np.int16. Shift enter and make sure that you are specifying comma over here, else you will get the same error. So now over here I am telling that the element will occupy 2 bytes of spaces within the memory. Why it is 2 bytes? So let's go back to the basics. Over here you already know that 8 bits equal to 1 byte, and here what we are specifying, we are telling that int16, that is if you divide 16 by 8, then you will get 2 bytes of information. So here we are telling that each space within the memory, within the data buffer is basically the term which is used within Numpy where we keep the actual data. So here we are specifying each space, each element will take the space of 2 bytes, that is called np.int16. Now this is one part of the story. Now the second part, first of all I will reiterate the point where I mentioned that within the memory the array is stored like this. That is actually wrong. Basically within the memory the data is being stored as homogeneous and the contiguous block. So how does it look like? Let's look into that. So it will look something like this. So all the array will be looked within the memory as contiguous block. So see here, within the memory it will be stored as like this, how you are seeing in this diagram. Now the question over here is how you can access the element from one position to another position. For example, if we are at position 0 0, if we consider if the first place is 0th position and you want to access this element, then how much byte you have to traverse from this position to this position. So that you need to calculate like this: 2 byte plus 2 bytes, 2 bytes plus 2 bytes. So 8 bytes you need to traverse to access this position. So that means you need to traverse these number of strides to access this element. So now you understand that what actually strides is. So now you understand the definition of strides. Strides are the number of bytes you need to step in each dimension when traversing the array. I hope I make you understand what actually the strides is. So now let's look into in Jupyter Notebook how we can get the strides information about an array. So to access the strides, it is pretty much straightforward. So what we need to do, we need to specify the name of an array, and there is a property called strides. And if you will press shift enter, then you will come to know that what actually the strides value for the given array. As we are having 6 elements, so to traverse this entire array to the last element, we need to traverse 6 byte in each dimension. For example, the last element we are having 3 over here. To access this 3, you need to access 6 byte. 2 plus 2 plus 2, that is 6 byte. Same is the case if you are traversing in this dimension to access the last element. So you need to traverse 2 plus 2 plus 2. So that's the reason it is telling that to access the last element of each dimension, you have to traverse near about 6 bytes. I hope I am able to make you understand what actually the strides is. If you have any question about strides, you can write me down. I will help you again to understand this concept. So on this note, I am stopping over here. This is what I wanted to demonstrate in this session. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.